I'm Alolita Sharma from Amazon Web Services. Super happy to be talking with you today at hnycon. And by background, I'm focused on open source observability at Amazon, and I'll be talking to you about all the cool work that we are doing building observability metrics in OpenTelemetry. For many of you who are already working in the observability space, there is a difference between monitoring, as you know of it, as well and observability. Monitoring, as you know, tells you whether a system is working or not. Observability is smarter. It tells you, and it asks you about why your systems aren't working. Observability also requires instrumentation and querying. And that's one of the areas that we're going to dive into with OpenTelemetry today. So what is OpenTelemetry? For most of you who are already working in the OpenTelemetry or the open source observability space, OpenTelemetry is a very popular CNCF project that everybody who is involved in the APM space, the observability space, or the monitoring frameworks is involved in. There are more than 250 organizations actively contributing to the project, as well as thousands of engineers who have contributed to the project with different components and code. OpenTelemetry provides, as all of you know, an open source observability agent, which is the collector, as well as instrumentation libraries and a standard data protocol called the OpenTelemetry Standard Protocol to unify monitoring, managing, and debugging applications and services. Interestingly enough, again, OpenTelemetry has been so popular that it has the mandate to support all the 3 data signals in telemetry, which are traces, metrics, and logs, in 11 languages, with some of the most popular languages like Java, Go, or JavaScript being supported, and at the same time, cool languages like Erlang, Rust, or Swift also having communities which are actively working on building instrumentation libraries. So why OpenTelemetry? Why do we care, right? Why do customers care? And that's one of the areas that customers have been asking for as they have built out observability or monitoring solutions over time, that they'd like to see a single collection agent that supports all types of telemetry data for them as they instrument their applications, as well as their infrastructure, and gather traces or metrics or logs. They'd like to see a single agent which is open source, interoperable across the OpenTelemetry standard, using a standard data protocol, providing a choice of different sources to ingest data from, as well as different destinations for monitoring that they may be using, as well as the ability to instrument once and deploy everywhere. It's super important that from a cost standpoint that customers have this choice available in a vendor-neutral way, which is open source. So OpenTelemetry meets those values, propositions very clearly, and hence customers have been really, really involved in being able to try out the technology, try out the collector, try out the instrumentation libraries, and continue to build out an instrument with it. So a little bit about me. I lead open source observability strategy and development at AWS. I'm also deeply involved in the open source, in the OpenTelemetry project, which is, I'm on the member of the governance committee of the project, as well as I lead some of the key initiatives of the project, such as the OpenTelemetry Prometheus Metrics Interoperability Work Group. I have also contributed to several OpenTelemetry Prometheus components and improvements across different libraries. My team also built the Prometheus Remote Write Exporter, which is super useful to many customers who are using the collector and are interested in sending their metrics to a Prometheus service. And I also lead the open source distribution for called the AWS Distro for OpenTelemetry, which is a downstream distribution available from AWS for OpenTelemetry. So needless to say, it is really interesting at this point in time to work on OpenTelemetry and building out metrics support and building out the library support as well as the collector support for it. Now, just to understand, why does metrics support need to be added to OpenTelemetry? As many of you know, OpenTelemetry is the result of two open source projects, which were very popular, combining together. OpenCensus, which was created and initially founded by Google and had a lot of metrics support built in, was one of the projects, and Open Tracing, that was created by Uber and other members, was the other project that was combined to becoming OpenTelemetry. And as we start to build metrics support, we inherit a lot of the underlying code as well as the implementation methods that OpenCensus had for metrics. So we carry that over, but yet now as we look at metrics support, natively out of the box in OpenTelemetry, we want to have feature parity as well as swap out some of the transformations that we have had OpenCensus support for and make it native to OpenTelemetry itself. In addition to that, using correlation context, tags, resources as frameworks, supporting more signals means supporting shared context for customers, providing those value props from the project to customers is a big deal. So the other aspect that I want to talk about is, as we are building out metrics support, this initiative, we started as the project, earlier this year. We had a big workshop, a full-day workshop, looking at what the requirements are that we needed to support and what we needed to build out to enable full metrics support in OpenTelemetry. And that meant changing 4 specific areas. One was, first of all, evaluating and understanding what data model changes needed to be made, as well as what OTLP protocol changes needed to be made. This includes instrumentation updates. This also means ensuring that the data model works for Prometheus and StatsD. It also means that OpenTelemetry can support Prometheus and StatsD out of the box. Similarly, API changes, which encompass defining and building an easy-to-use API for each metric type that is supported by OpenTelemetry, also enabling API owners to be able to easily update with stability assumptions guaranteed. On the SDK side, defining how metric types work in the SDK, enhancing the SDK if metric types are needed to be supported, or adding new metric types and ensuring that that is fully supported is important. And enabling the SDK to be able to leverage new metrics along within the API is also a requirement. In the collector itself, which is as I had shown earlier, is the out of process, pipeline for supporting metrics. Support for OTLP data ingestion and aggregation is a requirement, and that's one of the areas that we are starting to look at. Ensuring Prometheus and StatsD support. So we are currently working on the Prometheus interoperability requirements and building that out in the collector, and also enabling push and pull based implementation is a key requirement. So that said, again, how are we doing this, right? As you know, OpenTelemetry is a very large project, and there are many developers, many maintainers who are involved and are experts in having built large-scale telemetry systems before. So as we work together in the OpenTelemetry SIG meetings, as well as on the technical committees and discussions on the repos and in the issues and PRs themselves. We are actually working on multiple streams because, again, there is a huge anticipation that we will be rolling out metric support later this year. And in order to for an open source project to be organized and deliver, it collaboratively, standards as well as implementations that work out of the box and are fully stable, means that we split out, and kind of multitask and split out into work groups within the metrics SIG. For those of you who attend the metrics SIGs regularly, again, now instead of one metrics SIG meeting a week, we actually have multiple tracks ongoing at the same time. So usually we have 4 to 5 meetings a week, where we discuss design considerations, review PRs which are in progress, as well as discuss issues and questions that contributors may have. So what we have done is we have split out in multiple streams as work groups in the metrics SIG. One of these work groups is the working on the metrics data model, which is now stable, and with the requirements that the OTLP protocol also is fully supported with the metrics data type assumptions that we are making. Secondly, as I was initially alluding to, Prometheus Interoperability is a key goal of the project. And we have a Prometheus Interoperability work group, which I work on very actively as the second work group, where we have our own backlog, we have our own issues that we are tracking, and the key compliance requirements that we have for the Prometheus remote write specification that we are working on. And I'll dive into that a bit more later. Then we have the API and SDK stability discussions that are ongoing in a different work group. And what we are employing as a methodology is their rapid iteration on discussion items, prototyping and implementing this in specific, top languages as we build out the functionality. So the good news is that API work is actually underway right now and actually has almost become stable now, and SDK implementation and towards stability is also in progress. The fourth area, which is super important because collector is a very, very popular component in the project, is to make sure that OTLP data ingestion and aggregation is fully supported, ensuring OTLP pool-based implementation works, as well as scaling out the Prometheus push-based implementation to ensure that both protocols are well supported. And another area that we are, diving into is ensuring that each metric instrument is evaluated, and we look at the data types and ensure that there is an owner or a maintainer who's responsible for collecting feedback, driving discussions, owning implementation completion, and coordinating and collaborating with different maintainers and contributors who are working on different parts of the project. So needless to say, in such a large project, there's a fair bit of multitasking and also heavy amount of collaboration that is super exciting to be involved in, but also ongoing at a super fast rate. And if you're interested or involved in, looking at what's happening, you can easily catch up. The metrics SIG meetings are all recorded. They are available online on the OpenTelemetry YouTube channel, so you can go and check it out. So moving on, I'd like to dive in a little bit more into the Prometheus interoperability work that we are doing. And this is super important because, as many of you know, Prometheus is a very popular metrics monitoring and alerting framework, especially for Kubernetes-based applications. And for those of our customers who are not only have instrumented and monitoring and observability for other platforms which are non-Kubernetes based, there are requirements where there is a need for consuming or handling instrumentation metrics, both from applications as well as infrastructure, not only from Prometheus, but from other compute platforms too. And in the Prometheus workgroup specifically, what we are looking at is ensuring that the Prometheus protocol, especially for supporting all the data types, as well as the push-based protocol and pull-based protocol, are fully supported. And the data model especially is fully interoperable. So what does this interoperability mean? And is that, first of all, the OpenTelemetry metrics data model changes ensure Prometheus compatibility. Similarly, all metrics data types, including counter, gauge, summary, histograms, are fully supported. Prometheus components that are written in for the collector or the instrumentation libraries in different languages meet the remote and pass the remote write compliance tests. And the discovery and scrape configuration support in Prometheus receiver is also fully functional and supports the configuration needs that our customers are asking for. And similarly, stateful set support is available in the OpenTelemetry operator to support Kubernetes workloads and being able to support applications in that space. So lots of activity there. We have a full backlog for the Prometheus work group. If you're working in this place, please come and join us. We meet regularly on a weekly basis, as well as we have all our issues and tracking all the activity and the work that we are doing in order to extend this support. So moving forward, as you can see, I'm just taking in sharing the status updates that we maintain on the project website on OpenTelemetry.io for status. And metrics at this point, tracing, we are stable finally. And the last part that we are working on is the collector going stable also with full tracing support. So in parallel, the project is also working on metrics, as you can see. And that means that the API specification has finally reached stable, just happened this week. And we are currently working on the SDK, the collector, as well as the protocol, of course, with the data model has also gone stable. So we maintain this active update on the project website. You can go and check it out anytime, and it is pretty current. So on the last section, what I'd like to kind of dive into is a little bit more about what AWS is doing in this whole process in participating on OpenTelemetry. And needless to say, we've been super excited about participating in the open source observability space, especially on the OpenTelemetry project. One of the key areas, as I highlighted, many of our engineers are working in the Prometheus Interoperability work group, as well as I lead the work group. So that's been a really exciting area we're working on. Similarly, we have enhanced metrics support and helped enhance and add support in the collector. We have contributed and written the Prometheus Remote Write Exporter, CloudWatch Metrics Receiver and Exporter, a StatsD Receiver, and also have been working on several design proposals for some of the key components of the collector in order to be able to redesign and really be able to leverage a unified architecture for metrics processor. In the language library areas, we've been super active in the C++, on the C++ language library. That we built out metrics API and SDK as an initial experimental version last year. And then, of course, with the API and SDK stability work that is ongoing right now, we hope to take that to stable implementation. Similarly, have been adding and building out Prometheus exporters for language support, including C++, Go, Java, JavaScript, Python. And again, been deeply involved in all aspects of the metrics support work that has been ongoing, participating in code reviews and design reviews, and just excited to be working on different parts altogether. So I wanted to talk a little bit about two key initiatives that AWS has been involved in, especially for extending and supporting customers and users of OpenTelemetry. And we rolled out an AWS distro for OpenTelemetry, which is a downstream distribution of OpenTelemetry. We are deeply committed and contribute all source code for the distribution, any of the components that are bundled in it to the OpenTelemetry project. So all the source code that is available in the distribution is actually on the OpenTelemetry project. What we are doing is we are actually running security and predictive security and integration testing, which AWS runs at production quality for its services. We also actually do the due diligence from AWS's security guidelines to be able to support the distribution. We also offer AWS support for all components for customers who require this. We also are building out a one-click deploy and configuration for AWS container consoles, as well as AWS Lambda consoles, as well as have several receivers and exporters that, for the AWS monitoring solutions, such as CloudWatch or Elasticsearch, or the managed service for Prometheus or X-Ray, available in the distribution. And these components are all available upstream in the OpenTelemetry project also. We just bundle it downstream and make sure that this is fully tested and secure and performant for what we are delivering in the distribution. And last but not least, we are providing several integrations with partner solutions and partner service endpoints, including Honeycomb's support with the OTLP exporter and also other AWS partners. So go check out the distribution website at AWS OTel GitHub.io. And there's a lot of technical implementation and configuration details that you can find out. You can also go and check out the source code, the security testing results, the integration testing results. Everything is open source. You can go and check that out at this site. The other aspect that I wanted to talk about, which really is also a super cool feature that CloudWatch just rolled out recently, is the metric streams feature. And metric streams, again, can be used to stream CloudWatch metrics to a destination of your choice. And this is super exciting for customers because it promotes interoperability, which is a key mantra of OpenTelemetry also, where metric streams can be used for streaming CloudWatch metrics to a destination of your choice. You can take the Kinesis data firehose that is available to be able to stream any CloudWatch metrics from any accounts or any regions, to be pushing it to an Amazon S3 data lake or to a third-party destination. And that's pretty powerful because you can actually stream metrics into Honeycomb, for example. And the formats that are supported, which is something that is super exciting, is from an OpenTelemetry standpoint, is that this is OTLP compliant. So we do support from metric streams. You can dump the data out with OTLP 0.7 support or in JSON, depending on what your monitoring backend consumes. So go check it out. The documentation can be found on AWS's site. And I wanted to share some useful documentation and further reading links. So please go and check out the CloudWatch metric streams documentation. I have shared the links. Please feel free to take a look at the slides or take a snapshot to be going to these URLs. The AWS distro for OpenTelemetry documentation, all the technical documentation is available at AWS OTel GitHub.io. OTLP support for ADOT, which is how Honeycomb also connects and uses OTel collector through ADOT to connect into the Honeycomb backend services. These URLs are available right here. And last but not least, check out the observability engineering book that is actually being written by Liz Fong-Jones and Charity Majors and others of the Honeycomb team who are in the process of releasing this observability engineering book published by O'Reilly. I think you can go to this URL and go and check it out. Super excited again. I'm looking forward to reading it. Again, you know where to find us, but with that, I'd like to say thanks. Super excited to be at Honeycomb. And if you have any questions about OpenTelemetry metrics work or about AWS distro for OpenTelemetry, please feel free to reach out to me. I'm available on Twitter at Alolita or on GitHub at Alolita. And I also shared my contact at Amazon earlier. Thanks again, and look forward to any questions that you may have.
That was awesome. Thank you, Alolita. It's really exciting to see all of that. Cool. We've got a short Q&A here. I have a question for you, actually. So at Honeycomb, we're obviously super excited about OpenTelemetry, especially seeing AWS as a contributor. And I'm curious to ask you, what do you hope to see happen with the OpenTelemetry project itself in the community in the next couple of years?
Thanks, Yashin. Again, super excited to be part of the OpenTelemetry community, working closely with so many great contributors, maintainers and contributors from different companies as well as individual contributors. But I'm very excited about the future of OpenTelemetry. The future is bright, I think, and I'm looking forward to be part of the project for a long time, hopefully. Completing, I think there are lots of exciting initiatives from a project standpoint in terms of areas that we'd like to build out and accomplish. Some of those areas, again, is work in progress with the completing out and delivering a stable metrics, implementation across all the language libraries as well as the collector. And also the logging work that is in progress to support logging and having a full implementation end-to-end for supporting logs as the third pillar of observability is another exciting area that's ongoing. And long term, one of the things that I do envision is that the auto instrumentation of making it easier for customers to be able to use OpenTelemetry components out of the box, be able to run with them, make it as easy as and seamless as possible with the compute environments that OpenTelemetry runs on, whether that's Linux or Windows or Mac or even the Kubernetes and the other container environments. That will continue to grow and improve. So we have a lot of work ongoing there. I'd also, we are envisioning and very excited to kind of start thinking about in the next few months about building out a certification program and for compatibility with OpenTelemetry, very similar to what the Kubernetes project has implemented, but it's very essential to be able to provide and build trust with our customers and all users of OpenTelemetry, where they can have a very clear assessment of what they're building with, what versions are available, what's stable, what they can run with in production, and really continuing to build deeper infrastructure to support that. We have a really wonderful and awesome community and very inclusive community. It's one of the wonderful, nicest communities, open source communities I've worked with. I've been in open source a long time. And it's just exciting to see that energy. So I'm continuing, I think we will continue to keep growing that, building that energy, and also pulling in more, attracting more, great contributors to the project, building more plugins, extensions, more languages. So needless to say, I'm looking forward to the next, couple of years and more of the project.
That's fantastic. That's so exciting to hear. Thank you, Alolita, again.
Thank you again. And it's been a pleasure.